When we consider a logistic distribution on UI, we have what we call a logic regression model. Okay, the difference between the logic regression model and a probit regression model is on the specification of the link function, on the specification of the cumulative distribution function of epsilon I, or UI here. Okay, here when we assume that UI follow a standard normal distribution, we have a probit regression model. And if we assume that UI follow a logistic distribution, we have a cumulative distribution function of a logistic distribution. And we know here the two cumulative distribution function. So what we get, we have for a logic, this specification, a logic regression, we have just yi equal to the cumulative distribution function of xi beta plus epsilon I, and for a probit regression model, we have yi equal to the cumulative distribution function of a standard normal distribution on xi beta plus epsilon I. This is what we call the logic regression model. Since gamma is known, here we know both the cumulative distribution function of a logistic regression, because we are in a parametric setting. The link function is known. Here we have gamma on xi beta is equal to 1 over 1 plus exponential of minus xi beta. This is the expression of this link function. So here we have a nonlinear link function. That is why the logic regression model is also a nonlinear regression model. And for a probit, we have the cumulative distribution function of a probit regression is given by this sum on minus l'infini xi beta on 1 over. Here we have a probability density function of a standard normal distribution on z. I do the sum of a continuous dependent variable because here I assume a normal distribution. This is the cumulative distribution of a standard normal distribution. Here we have a logic and a probit regression. And to estimate the parameters, we use just the maximum likelihood estimation method. I compute the likelihood, the log likelihood, and I maximize using a numerical optimization method. Beta and beta MLE is the solution of the maximization of the log likelihood associated to all observations associated to my sample yi until yn, given beta. And here I use an optimization method to get the solution of the first order condition of this maximization problem. Okay, I know how to write a log likelihood in using a probit or logic regression. For the log likelihood, we consider here, as we have seen, the sum of a log. Here for each observation, what we get the probability yi times 1 minus the probability on 1 minus yi. Because if yi is equal to 1, we get the probability of realization, and if yi is equal to 0, we get 1 minus the probability of realization. And if we consider the log likelihood, here we have for the likelihood we consider the product, and for the log likelihood we have the sum of this logarithmic part. Here we have yi log of the probability of realization pi plus 1 minus yi, the logarithm of the probability 1 or just the probability of yi equal to 0. Okay, and here I have the log likelihood, and I can compute the score in the first order condition and the Hessian in the second order condition. And I estimate by maximum likelihood the parameters in a logic and probability regression model.